In the early months of 1943, as the thunder of armored warfare raged fiercely across the battlefields of Europe and North Africa, the M4 Sherman tank stood as a symbol of American industrial might and battlefield reliability. Yet beneath its familiar silhouette lay a growing tension, a gap between its dependable performance and the escalating demands of war. The Sherman, while robust and mechanically sound, was increasingly outmatched by the formidable German armor it faced. Commanders and crews alike recognized that the tank, once a workhorse of American armored divisions, was straining under the pressure of evolving battlefield realities. This tension set the stage for what would become a critical chapter in armored warfare, the urgent drive to upgrade the Sherman tank and restore its battlefield edge. As the war intensified in early 1943, engagements such as those in Tunisia and Sicily underscored a stark truth. The Sherman's 75mm main gun, adequate in earlier confrontations, struggled to penetrate the thick frontal armor of German Panther and Tiger tanks. These adversaries, equipped with heavier armor and longer range, more powerful weaponry, commanded the battlefield with a psychological and tactical advantage that American forces could not afford to ignore. The initial reliability and mobility that had made the Sherman a favored platform were now overshadowed by its inability to effectively counter the feared German heavy tanks. This created a critical vulnerability. American tank crews found themselves outgunned and at increased risk, a dangerous predicament that called into question the Sherman's future relevance. The American armored divisions were, in many respects, caught between two competing realities. On one hand, the Sherman was mechanically sound, relatively fast, and easier to produce and maintain than its German counterparts. Its operational reliability and logistical simplicity had already proven invaluable in multiple theaters. On the other hand, the battlefield was increasingly dominated by German tanks with superior firepower and armor protection. The Panther's 75mm KWK-42 gun, capable of penetrating the Sherman's armor at long ranges, and the Tiger's devastating 88mm gun, which could destroy Allied tanks with a single shot, created a formidable challenge. American tank crews, operating Shermans armed with the standard 75mm gun, often found themselves forced into close-quarters engagements, relying on maneuver and numbers rather than firepower, a precarious strategy against such lethal opposition. This disparity was not lost on frontline commanders or the men who operated these tanks daily. Reports from the front lines painted a clear picture. The Sherman's gun was insufficient against the newer German armored designs, and its armor, while adequate against earlier threats, was increasingly vulnerable to the more powerful German rounds. The psychological impact on American tank crews was profound. Confidence in their equipment was a critical factor in combat effectiveness, and the perceived inferiority of the Sherman's firepower undermined morale. Additionally, tactical doctrine had to be adapted constantly to compensate for these shortcomings, emphasizing combined arms cooperation and numerical superiority to offset the Sherman's disadvantages. Yet, these measures were stopgaps rather than solutions. The urgency to address this imbalance became a focal point for American military planners and engineers. The evolving battlefield demanded a tank that could not only survive but also dominate against the upgraded German armor. The Sherman's chassis, proven and versatile, was seen as an ideal platform for enhancement. However, the challenge was clear: any upgrade needed to significantly increase firepower without sacrificing the Sherman's hallmark mobility and reliability. This balance was critical. A tank that was more heavily armed but slower or less mechanically reliable would only replace one set of problems with another. American engineers, therefore, faced the complex task of innovating within the constraints of existing production lines and battlefield requirements. The context of 1943 was marked by rapid technological advancements and shifting tactical paradigms. The Allies were preparing for increasingly large-scale operations on the European continent, where armored units would play decisive roles. The anticipated invasion of France and the ongoing battles in Italy and North Africa demanded that American armored forces be equipped with vehicles capable of countering the best the Germans could field. The Sherman's limitations threatened to undermine operational plans, making the push for an upgrade not just desirable but essential. Military leadership recognized that failure to improve the Sherman's effectiveness could result in higher casualties and potentially jeopardize broader strategic objectives. American tank crews, having experienced the brutal encounters with German Panthers and Tigers, provided vital feedback that shaped the direction of the upgrade effort. Their frontline experiences highlighted specific weaknesses: the insufficient penetration capability of the 75mm gun against heavy armor, the vulnerability of the tank's turret and frontal armor to enemy fire, and the need to maintain the vehicle's renowned mobility and mechanical reliability. This feedback loop between the battlefield and the engineering corps was crucial, ensuring that the upgrade would be grounded in practical, combat-tested requirements rather than theoretical improvements. It was a testament to the effective integration of operational experience into technological innovation. The Sherman's role in the wider Allied armored strategy further underscored the necessity of its enhancement. Unlike German tank production, which favored fewer but heavily armored and armed vehicles, American doctrine emphasized mass production and combined arms tactics. The Sherman, as the backbone of American armored forces, needed to fulfill this strategy by being both numerous and capable. Any upgrade had to maintain the Sherman's production efficiency. A complex, expensive, or slow-to-produce tank would conflict with the overarching Allied advantage in industrial capacity. Thus, the challenge was not only technical but also logistical and strategic, to deliver an upgrade that could be produced at scale and deployed rapidly to the front lines. This period marked a pivotal moment in the evolution of American armored warfare. The Sherman, once a symbol of dependable but modest capability, was poised for transformation. The urgency born from battlefield experience, combined with the strategic imperatives of the broader war effort, catalyzed a concentrated effort to enhance the tank's firepower and survivability. The year 1943 thus stands as a watershed in the Sherman's history, a turning point where American engineers and military planners confronted the pressing realities of armored combat and sought to redefine the Sherman's role on the battlefield. In doing so, they laid the groundwork for innovations that would significantly alter the dynamics of armored warfare in the years to come. The shortcomings of the original Sherman tank became increasingly evident as American forces confronted the lethal efficiency of German armored units. The M4 Sherman, armed with its standard 75mm M3 gun, was initially designed to balance firepower, mobility, and production efficiency. However, by early 1943, it was clear that this balance was skewing unfavorably against the heavy German tanks dominating the battlefield. The 75mm gun, though effective against earlier Axis vehicles and infantry positions, struggled to penetrate the thick frontal armor of the Panther and Tiger tanks. This deficiency exposed a critical vulnerability. The Sherman could neither reliably engage nor destroy these formidable opponents at typical combat ranges, a fact that undermined its tactical effectiveness and endangered its crews. The limitations of the 75mm gun were technical and tactical. Its armor-piercing rounds lacked the velocity and penetration necessary to breach the Panther's glacis plate or the Tiger's turret front. The German tank's sloped armor design further reduced the likelihood of a successful penetration, rendering many Sherman's shots ineffective. This firepower gap forced American crews to adopt risky tactics, such as flanking maneuvers or waiting for close-range opportunities where the 75mm gun could be decisive. However, these tactics were hazardous and often impractical in the fluid, fast-paced armored battles that characterized the European theater. The inevitable result was increased Sherman losses and diminished battlefield momentum. Alongside firepower, the Sherman's armor protection revealed its own set of vulnerabilities. The tank's armor thickness, while sufficient against earlier anti-tank weapons and lighter enemy vehicles, was increasingly inadequate against the heavy German guns. The turret front and hull faced the greatest threats, with many Shermans succumbing to the powerful 88mm and high-velocity 75mm rounds fired by German tanks and anti-tank guns. The relatively thin armor was a necessary compromise to maintain mobility and production speed, but it meant that Shermans were often at a disadvantage in direct confrontations. This vulnerability not only threatened the physical survival of the tank, but also eroded crew confidence, a crucial factor in armored warfare effectiveness. Despite these weaknesses, the Sherman retained significant mobility advantages. Its reliable engine and suspension system allowed it to maneuver effectively over diverse terrain, a critical asset in the fast-moving battles of the war. This mobility was a key component of American armored doctrine, which emphasized maneuver warfare, combined arms coordination, and rapid exploitation of breakthroughs. However, the Sherman's firepower shortcomings meant that its mobility was not fully leveraged. The tank often had to avoid direct engagements with heavily armored German opponents or rely on support from infantry, artillery, and air assets. The disconnect between the Sherman's mechanical agility and its offensive capability underscored the urgent need for a comprehensive upgrade. Frontline feedback from American tank crews and commanders was instrumental in identifying and prioritizing these deficiencies. Reports consistently highlighted the frustration and danger posed by the Sherman's inability to effectively engage German heavy tanks. Crews recounted harrowing encounters where their rounds bounced harmlessly off enemy armor, leaving them vulnerable to retaliatory fire. Commanders noted the tactical constraints imposed by the Sherman's limited firepower, which complicated planning and execution of armored assaults. This candid assessment from the battlefield provided a clear mandate for engineers and military planners. The Sherman required a more powerful main gun and enhanced armor protection to restore its combat effectiveness. The nature of these weaknesses was multifaceted. The 75mm gun's limitations were not merely about caliber size, but also about muzzle velocity and ammunition types. The standard armor-piercing rounds lacked the penetration power to defeat the composite and sloped armor of late-war German tanks. Moreover, the Sherman's turret design constrained the size of the gun that could be mounted without significant modifications. Armor protection, meanwhile, was balanced against weight considerations. Increasing armor thickness risked compromising the Sherman's mobility and mechanical reliability. These engineering challenges complicated the task of upgrading the tank without sacrificing its core strengths. The constraints of existing production and logistical frameworks further compounded the challenge. The Sherman was produced in vast numbers, with multiple variants designed for different roles and theaters. Any upgrade had to be compatible with existing manufacturing processes and supply chains to avoid disrupting the flow of tanks to the front. This necessity for continuity limited the scope of possible modifications and required innovative engineering solutions to integrate more powerful weaponry and improved armor within the Sherman's existing design envelope. In this context, the identification of weaknesses was not only a technical exercise but a strategic imperative, balancing battlefield demands with industrial realities. American tank crews' combat experience also revealed the importance of crew ergonomics and visibility in combat effectiveness. The Sherman's turret design, while functional, offered limited space and visibility, which affected targeting efficiency and situational awareness. These factors, while secondary to firepower and armor, contributed to the overall effectiveness of the tank in combat. The cumulative effect of these technical and operational shortcomings underscored that an incremental upgrade was insufficient. A comprehensive approach addressing firepower, armor, and crew efficiency was necessary to restore the Sherman's battlefield competitiveness. This period of critical evaluation and analysis set the stage for a transformative phase in Sherman tank development. The identification of specific weaknesses, primarily the inadequate 75mm gun, vulnerable armor, and underutilized mobility, provided a focused framework for subsequent engineering efforts. The American military-industrial complex, supported by detailed feedback from the front lines, embarked on a mission to enhance the Sherman's lethality without compromising its reliability and production efficiency. This mission would lead to significant innovations, including the development of a more powerful gun and suspension improvements, which collectively redefined the Sherman's role in armored warfare. The technical shortcomings of the original Sherman were thus not merely obstacles but catalysts for innovation. They highlighted the evolving nature of armored combat and the necessity of adaptability in military technology. The balance between firepower, protection, and mobility, a triad critical to tank effectiveness, was recalibrated in response to the Sherman's battlefield challenges. This recalibration was driven by a pragmatic understanding that success would not come from entirely new designs, but from intelligent, focused upgrades that leveraged the proven Sherman chassis and production infrastructure. The lessons learned during this phase would resonate far beyond the immediate context, influencing armored warfare doctrine and tank design philosophy for decades. In summary, the original M for Sherman tank's 75mm gun was insufficient against the heavy German tank's advanced armor and firepower, exposing vulnerabilities in both offense and defense. While its mobility remained a strength, it was not effectively exploited due to the firepower deficit. Frontline feedback underscored the critical need for enhancements, driving American engineers to confront the challenge of integrating more powerful weaponry and improved protection without sacrificing the Sherman's operational advantages. This analysis of weaknesses laid the essential groundwork for the subsequent development of the Sherman tank upgrade, marking a pivotal moment in the evolution of Allied armored warfare. In response to the pressing need to enhance the Sherman tank's firepower, American engineers launched an ambitious program to mount a more powerful gun on the proven M4 chassis. Central to this effort was the decision to equip the Sherman with the 76mm high-velocity gun, a weapon capable of significantly improving armor penetration and engagement range. This upgrade promised to address the critical shortcomings of the original 75mm gun, providing tank crews with the means to directly challenge the formidable German Panthers and Tigers that had dominated armored battles. However, the path to integrating the 76mm gun was fraught with complex engineering challenges that demanded innovative solutions and meticulous collaboration across multiple disciplines. The 76mm gun, with its longer barrel and larger caliber, presented inherent difficulties in fitting within the Sherman's turret and maintaining the tank's overall balance and mobility. Unlike the 75mm gun, the 76mm required a larger turret ring, and additional internal space to accommodate its recoil mechanism and ammunition storage. This necessitated modifications to the turret structure, including reinforced armor to protect the larger gun mount and adjustments to the turret's internal layout to ensure crew efficiency and safety. The challenge was to implement these changes without increasing the tank's overall weight to a degree that would compromise its mechanical reliability or cross-country performance. American engineers approached these problems with a combination of practical ingenuity and rigorous testing. Ordnance experts, tank designers, and manufacturing specialists worked closely to develop a turret capable of housing the 76mm gun while preserving the Sherman's essential characteristics. This collaboration extended from design bureaus to production plants, ensuring that the new turret could be manufactured efficiently and integrated into existing assembly lines without major disruptions. The result was a carefully balanced design that leveraged advances in metallurgy and fabrication techniques, enabling the production of a turret that was both stronger and more spacious than its predecessor. Testing phases played a critical role in validating the 76mm gun's integration with the Sherman chassis. Prototypes underwent extensive firing trials to assess recoil behavior, accuracy, and mechanical stresses on the turret and suspension systems. These trials were conducted under simulated battlefield conditions to ensure that the upgraded tank could withstand the rigors of combat without mechanical failure. Engineers also evaluated the gun's ability to penetrate various types of German armor at different ranges, confirming that the 76mm gun provided a decisive improvement over the 75mm. The positive results from these tests bolstered confidence that the upgrade would restore the Sherman's battlefield effectiveness. A crucial aspect of the development process was the refinement of ammunition types compatible with the 76mm gun. While the gun's design allowed for higher muzzle velocity and improved penetration, the effectiveness of the tank's firepower depended heavily on the availability of suitable armor-piercing and high-explosive rounds. Ordnance specialists developed new shells with enhanced ballistic properties, optimized for the 76mm's capabilities. These munitions were designed to defeat the sloped armor of German tanks and to provide versatility against a range of targets, including fortified positions and infantry concentrations. The synergy between gun design and ammunition development was a key factor in maximizing the Sherman's combat potential. The integration of the 76mm gun also required adaptations in crew training and tactical doctrine. Tank crews had to familiarize themselves with the new weapon's ballistics, aiming mechanisms, and firing procedures. Maintenance personnel received additional instruction on the care and repair of the more complex gun system. This comprehensive training ensured that the upgraded Shermans could be employed effectively and reliably from the moment they reached the front lines. Moreover, commanders adjusted tactics to leverage the extended engagement ranges and improved penetration, allowing American armored units to confront German heavy tanks with greater confidence and flexibility. Manufacturing the upgraded Sherman with the 76mm gun involved significant coordination among several key industrial players. Major automotive and armaments companies, including Ford and Chrysler, adapted their production lines to accommodate the new turret and gun assembly. This transition had to be managed carefully to maintain the pace of tank deliveries essential for ongoing campaigns. The ability to integrate the 76mm gun into mass production without substantial delays was a testament to the organizational prowess and industrial capacity of the American war effort. It ensured that upgraded Shermans could be deployed in sufficient numbers to influence armored engagements decisively. The decision to enhance the Sherman's firepower with the 76mm gun reflected a broader strategic understanding of armored warfare's evolving demands. While the original Sherman had been designed for versatility and ease of production, the realities of combat required a shift toward increased lethality without sacrificing the tank's inherent strengths. The 76mm upgrade struck this balance by providing a significant increase in anti-armor capability while preserving the Sherman's mobility and mechanical reliability. This pragmatic approach exemplified American military engineering's capacity to adapt existing platforms to meet new challenges swiftly and effectively. Throughout the development process, American engineers remained acutely aware of the limitations imposed by the Sherman's chassis and turret design. Although the 76mm gun represented a substantial improvement, it was not without compromises. The longer barrel increased the tank's profile, potentially affecting concealment, and the reduced turret interior space placed additional demands on the crew. Yet, these trade-offs were deemed acceptable given the dramatic enhancement in firepower and the strategic necessity of countering German heavy tanks. This balanced perspective underscored the practical nature of the upgrade, focusing on achievable improvements rather than idealized redesigns. The introduction of the 76mm gun into the Sherman's arsenal was more than a technical upgrade. It signaled a shift in the balance of armored warfare. American tank crews, previously forced into cautious engagements against German heavy armor, now possessed a weapon capable of contesting enemy tanks at greater ranges and with increased lethality. This shift had immediate tactical implications, enabling more aggressive maneuvers and reducing reliance on numerical superiority or external support. The upgraded Sherman could now fulfill the role of a frontline tank hunter rather than merely a support vehicle, altering the dynamics of tank battles across European battlefields. This phase of innovation also illustrated the broader American approach to wartime technological challenges. Faced with an urgent need to improve existing equipment, engineers and military planners leveraged their industrial base's flexibility and expertise to implement effective solutions rapidly. The successful integration of the 76mm gun into the Sherman tank chassis demonstrated how incremental yet impactful technological advancements could be deployed at scale, sustaining combat effectiveness without the delays associated with entirely new tank designs. This approach would become a hallmark of American armored vehicle development throughout the war. In essence, the development and integration of the 76mm high-velocity gun onto the Sherman tank chassis represented a decisive response to battlefield exigencies. American engineers overcame significant technical hurdles to mount a weapon that restored the Sherman's competitiveness against German heavy tanks. Through collaborative design efforts, rigorous testing, and coordinated production, the upgraded Sherman emerged as a more formidable instrument of armored warfare. This transformation not only enhanced the tank's tactical capabilities, but also reinforced the synergy between American industrial strength and military innovation, a combination that would prove critical in the ensuing battles of World War II. While the integration of the 76mm high-velocity gun marked a significant leap forward in the Sherman tank's firepower, American engineers recognized that this upgrade had to be complemented by enhancements to the tank's suspension and overall mobility to fully realize its battlefield potential. The original Sherman's vertical volute spring suspension, VVSS, though reliable, limited the tank's stability and cross-country performance, especially when accommodating the increased weight and recoil forces associated with the new armament. Addressing these mechanical constraints became a priority, leading to the development of an improved suspension system that would not only support the 76mm gun, but also enhance crew comfort, firing accuracy, and maneuverability. This evolution culminated in the M4A3E8 variant, widely known as the EZ8, which symbolized the culmination of these concurrent upgrades. The vertical volute spring suspension system had served the Sherman well during its initial deployments, providing a balance between simplicity, ease of maintenance, and acceptable ride quality. However, as battlefield demands intensified, the limitations of the VVSS became apparent. Its relatively narrow track and suspension design constrained the tank's ability to absorb shocks from rough terrain, leading to reduced stability during firing and increased crew fatigue over extended operations. These factors were particularly evident when the Sherman was equipped with the heavier 76mm gun, which introduced greater recoil forces and required a more stable firing platform to maximize accuracy. The need for a suspension capable of accommodating these stresses without sacrificing mobility became a critical engineering challenge. In response, American engineers turned to the horizontal volute spring suspension, HVSS, a more advanced system that offered improved shock absorption and a wider track profile. The HVSS design replaced the vertical springs with horizontally mounted volute springs, which distributed mechanical loads more evenly and allowed for greater wheel travel. This innovation translated into a smoother ride over uneven terrain, enhanced stability when firing on the move or from stationary positions, and reduced wear on suspension components. The wider tracks also decreased ground pressure, improving the Sherman's ability to traverse soft or muddy ground, conditions frequently encountered on European battlefields. Collectively, these improvements addressed key mobility and stability issues that had limited the Sherman's combat performance. The adoption of the HVSS system was a complex engineering endeavor that required modifications to the tank's hull and running gear. The suspension mounts were redesigned to accommodate the new spring orientation and wider track assembly, necessitating adjustments in the tank's weight distribution and balance. These changes were carefully engineered to maintain the Sherman's overall reliability and mechanical simplicity, avoiding overcomplication that could hinder field repairs and maintenance. Extensive testing validated the HVSS's durability and performance, confirming that it enhanced the Sherman's operational capabilities without introducing new vulnerabilities. This balance of innovation and pragmatism reflected the American approach to wartime engineering challenges. The M4A3E8, EZ-8, emerged as the embodiment of these concurrent upgrades, combining the 76mm high-velocity gun with the horizontal volute spring suspension system. This variant represented a significant evolution in the Sherman's design philosophy, emphasizing a harmonious integration of firepower, protection, and mobility. The EZ-8 nickname, derived from its model designation, belied the profound tactical advantage it conferred on American armored units. Crews operating the M4A3E8 reported improved ride comfort, reduced fatigue, and enhanced firing stability, factors that directly translated into greater battlefield effectiveness. The improved suspension allowed tankers to maintain higher speeds over rough terrain and to engage targets with increased accuracy, elevating the Sherman's status from a reliable workhorse to a more formidable combat platform. Crew comfort, often overlooked in armored vehicle design, proved to be a vital component of the EZ-8's success. The smoother ride provided by the HVSS reduced physical strain and vibration exposure, allowing tank crews to operate more effectively during prolonged engagements. Enhanced ergonomics within the tank, facilitated by the additional internal space gained through suspension modifications, improved crew coordination and situational awareness. These factors collectively contributed to higher morale and combat readiness, underscoring the importance of mechanical improvements beyond pure firepower or armor considerations. The EZ-8 thus represented an integrated solution addressing multiple facets of armored warfare. Firing accuracy also benefited significantly from the suspension upgrade. The HVSS's superior shock absorption minimized the disruptive effects of terrain-induced vibrations when aiming and firing the 76mm gun. This stability allowed gunners to engage enemy targets with greater precision, increasing the likelihood of first-shot kills and reducing ammunition expenditure. In the dynamic environment of armored combat, where split-second decisions and accurate fire could determine survival, these improvements were invaluable. The enhanced suspension system effectively extended the operational envelope of the Sherman tank, enabling it to perform more effectively in a broader range of combat scenarios. Cross-country mobility, a defining characteristic of the Sherman since its inception, was further enhanced by the HVSS system. The wider tracks reduced ground pressure, allowing the tank to negotiate soft soils, mud, and uneven terrain with greater ease. This capability was particularly important in the varied landscapes of the European theater, where tanks often faced challenging environmental conditions. The improved traction and stability facilitated rapid maneuvering, enabling American armored units to exploit breakthroughs, reposition quickly in response to enemy movements, and maintain operational tempo. By preserving and enhancing the Sherman's mobility, the suspension upgrade ensured that the tank's offensive capabilities could be fully leveraged on the battlefield. The integration of suspension improvements with the 76mm gun upgrade was a deliberate strategy to create a more balanced and effective armored fighting vehicle. Rather than focusing solely on firepower, American engineers recognized the necessity of addressing the interconnected systems that influenced the Sherman's combat performance. This systems-level approach distinguished the M4A3E8 from earlier variants and exemplified the maturation of American armored vehicle design during World War II. The synergy between mechanical upgrades and armament enhancements underscored the importance of a holistic perspective in military engineering, where individual improvements must function cohesively to produce a decisive battlefield advantage. Production of the EZ-8 variant was facilitated by the American wartime industrial machine, which adapted quickly to incorporate the new suspension system alongside the 76mm gun installation. Factories retooled assembly lines to accommodate the more complex suspension components without sacrificing output volume. This rapid industrial adaptation ensured that the improved Shermans reached frontline units in time to influence key campaigns in late 1944 and beyond. The ability to field large numbers of upgraded tanks reflected not only technological achievement, but also logistical and organizational excellence, critical factors in sustaining armored operations across multiple theaters. The tactical benefits of the EZ-8 became apparent in combat, where its combined firepower and mobility allowed American forces to engage German armored threats more effectively. The improved suspension enabled tank units to maintain formation integrity and speed during rapid advances and defensive maneuvers. This mobility, coupled with the enhanced 76mm gun, allowed tank commanders greater flexibility in deploying their forces, executing flanking attacks, and supporting infantry operations. The EZ-8 thus played a vital role in the evolving combined arms tactics that characterized late-war Allied offensives, contributing directly to battlefield successes and the attrition of German armored forces. In summary, the introduction of the horizontal volute spring suspension system alongside the 76mm gun upgrade transformed the Sherman tank into a more capable and versatile weapon system. The M4A3E8 EZ-8 variant embodied this evolution, delivering improved stability, crew comfort, firing accuracy, and cross-country mobility. These mechanical enhancements complemented the increased firepower, creating a synergistic effect that elevated the Sherman's battlefield performance. This phase of development highlighted the importance of integrated engineering solutions that addressed multiple aspects of tank effectiveness, setting a new standard for American armored vehicles in the final years of World War II. By mid-1944, the upgraded Sherman tanks equipped with the 76mm high-velocity gun and improved suspension systems began to see widespread deployment in key Allied campaigns, most notably the grueling battles following the Normandy landings and the fierce confrontations during the Battle of the Bulge. These upgraded Shermans, embodying both enhanced firepower and mobility, brought a renewed sense of confidence to American armored units facing the previously overwhelming German Panther and Tiger tanks. The tactical landscape of armored warfare was shifting, as the battlefield advantage began to tilt in favor of the Allies, challenging German armored dominance in ways that commanders on both sides had not fully anticipated. The initial deployments of the 76mm armed Shermans demonstrated a marked improvement in American forces' ability to engage and neutralize German heavy tanks at greater distances, and with higher hit probabilities. Unlike the earlier 75mm variant, which often forced crews into dangerous close-range encounters, the 76mm gun allowed Sherman tankers to contest enemy armor more effectively across typical combat ranges. This capability was critical in the bocage country of Normandy, where the dense hedgerows and uneven terrain complicated tank maneuvers and engagement distances. The upgraded Shermans could now penetrate Panther glacis plates and threaten Tiger turrets with a level of firepower that previously had been unattainable, enabling more aggressive tactics and reducing reliance on numerical superiority alone. Tactical adjustments accompanied these mechanical improvements. American armored units adapted their operational doctrines to exploit the Sherman's enhanced firepower and mobility. Rather than avoiding direct confrontations with heavy German tanks, Sherman crews were trained to engage with confidence, utilizing the tank's improved gun and stability to deliver accurate, disabling shots. Combined arms tactics were refined, with infantry and artillery support coordinated to maximize the Sherman's strengths and mitigate remaining vulnerabilities. This evolution in tactics reflected a growing understanding that the upgraded Sherman was no longer merely a support vehicle but a formidable frontline contender in armored warfare. Several notable battles during late 1944 and early 1945 illustrated the tangible impact of the Sherman upgrade. In the dense forests and rolling hills of the Battle of the Bulge, American armored units employing the 76 mm armed Shermans played a crucial role in halting and repelling the German Ardennes offensive. The ability to engage Panther and Tiger tanks effectively at range allowed American forces to blunt the armored spearheads that had initially achieved surprise and penetration. Instances of Sherman crews successfully destroying German heavy tanks, often under challenging conditions and against numerically superior forces, underscored the upgrade's battlefield effectiveness. These encounters not only inflicted material losses but also had a psychological impact on German tank crews, who now faced a more lethal adversary than before. The psychological effect of the upgraded Sherman cannot be overstated. German tank crews, accustomed to a relative advantage in armor and firepower, found themselves confronting a new reality. The presence of Shermans capable of matching their tanks' lethality forced German commanders to reconsider engagement strategies, often favoring caution over aggression. This shift influenced German armored doctrine and operational planning, as the once dominant Panther and Tiger were increasingly countered by a tank that combined improved firepower with superior mobility and reliability. The psychological edge gained by the Allies contributed to the gradual erosion of German armored effectiveness as the war progressed. The upgraded Shermans were also deployed in diverse theaters beyond Normandy and the Ardennes, including the Italian campaign and the push into Germany itself. Their improved capabilities allowed American armored units to operate effectively in varied terrain, from open plains to urban environments. The Sherman's enhanced suspension and firepower facilitated rapid advances and flexible defensive actions, enabling commanders to respond dynamically to evolving battlefield conditions. This versatility was a critical factor in sustaining the momentum of the Allied advance, as armored units could exploit breakthroughs and adapt to German counterattacks with greater efficacy. Despite these advances, the Sherman upgrade did not render the tank invulnerable. German heavy tanks still possessed advantages in armor thickness and firepower, and tactical skill remained essential to avoid costly engagements. However, the improved Sherman's ability to survive and fight back effectively altered the cost-benefit calculus for German armored forces. The increased risk of loss and the declining psychological advantage weighed heavily on German operational decisions, contributing to a defensive posture increasingly focused on attrition and preservation rather than decisive armored maneuvers. In this sense, the Sherman upgrade played a strategic role in undermining German armored initiatives. The battlefield advantage gained by American forces was not solely the result of mechanical improvements, but also the product of integrated tactics and operational art. The Sherman's enhanced firepower and mobility were leveraged through coordinated combined arms operations, where infantry, artillery, engineers, and air support worked in concert with armored units. This synergy amplified the Sherman's effectiveness and mitigated its remaining weaknesses, such as relatively thin armor and limited turret traverse speed. The upgraded Sherman thus became a key component of a broader operational system that emphasized flexibility, coordination, and sustained pressure against German forces. The deployment of the upgraded Sherman also influenced enemy force composition and deployment. As the Allies introduced more capable Shermans, German commanders faced increasing difficulties in maintaining armored superiority. Production challenges, fuel shortages, and logistical constraints limited Germany's ability to field sufficient numbers of Panther and Tiger tanks, particularly as the war dragged on. The presence of effective Sherman tanks on the battlefield compounded these difficulties, forcing German forces to contend with a more balanced and resilient opponent. This changing dynamic contributed to the progressive erosion of German armored strength and operational freedom. In the crucible of late-war armored engagements, the upgraded Sherman exemplified the successful translation of engineering innovation into battlefield advantage. The combination of the 76mm gun and improved suspension allowed American tank crews to confront German heavy tanks with renewed confidence and tactical flexibility. These technological and tactical gains translated into tangible battlefield successes, influencing the outcome of critical campaigns and contributing to the eventual Allied victory in Europe. The Sherman's transformation from a reliable yet outgunned tank into a credible opponent against the best German armor marked a significant shift in armored warfare dynamics. The experiences of American armored units employing the upgraded Sherman during this period underscored the importance of adaptability and continuous improvement in military technology. The ability to respond to emerging threats with effective upgrades, combined with corresponding tactical evolution, proved decisive in restoring balance on the battlefield. The upgraded Sherman's impact extended beyond mere hardware. It reshaped the psychological and operational landscape of armored combat, compelling German forces to grapple with a new and more formidable adversary. This phase of the Sherman's service demonstrated the critical interplay between technology, tactics, and morale in determining armored warfare outcomes. In summary, the deployment of the upgraded Sherman tanks with their 76mm guns and improved suspension during pivotal 1944 campaigns signaled a turning point in Allied armored warfare. By overcoming previous firepower and mobility limitations, these tanks challenged the dominance of German Panthers and Tigers, enabling more effective offensive and defensive operations. The tactical adaptations, battlefield successes, and psychological effects of this upgrade collectively contributed to shifting the balance of armored power in favor of the Allies, setting the stage for the final phases of the European conflict. The introduction of the 76mm gun on the Sherman tank was a pivotal upgrade, but its full battlefield potential depended heavily on the parallel development of improved ammunition types and the evolution of tactical doctrine to exploit these advancements. Recognizing that weapon effectiveness was inseparable from the quality of its ammunition, American ordnance specialists devoted significant effort to designing new armor-piercing and high-explosive rounds tailored to the 76mm's characteristics. These efforts ensured that the Sherman's enhanced firepower could be translated into decisive battlefield effects, while the adaptation of tactical training and doctrine maximized the tank's operational impact. A primary focus was the development of armor-piercing rounds capable of countering the advanced German tank designs. Early 76mm rounds, while more powerful than their 75mm predecessors, initially struggled against the thick, sloped armor of Panther and Tiger tanks, particularly at longer ranges. To overcome this, ordnance experts engineered improved armor-piercing capped ballistic capped APCBC projectiles with hardened penetrators and optimized aerodynamic shapes. These rounds achieved higher penetration capabilities by combining increased velocity with enhanced shell design, allowing Shermans to engage German heavy tanks more effectively at combat distances. The incremental improvements in ammunition design were critical in closing the firepower gap and restoring confidence among tank crews. In addition to armor-piercing rounds, the 76mm gun's ammunition suite included new high-explosive, heat, shells designed for versatility on the battlefield. These rounds provided Shermans with the ability to engage a variety of targets beyond armored vehicles, such as fortified positions, bunkers, and infantry concentrations. The improved He shells featured better fragmentation patterns and explosive yields, enhancing the Sherman's role in combined arms operations and supporting infantry advances. This versatility was particularly valuable in the diverse combat environments of the European theater, where Shermans often faced mixed threats requiring adaptable firepower. The development of these new ammunition types was closely integrated with the training of American tank crews. Crews received comprehensive instruction on the ballistic properties, optimal engagement ranges, and tactical applications of the 76mm gun's varied ammunition. This education enabled tankers to select the appropriate round for specific combat scenarios, improving combat efficiency and ammunition conservation. For example, crews learned to prioritize armor-piercing rounds against enemy tanks while reserving high-explosive shells for soft targets or defensive structures. This tactical awareness maximized the Sherman's lethality and contributed to more effective use of limited ammunition supplies in the field. Training extended beyond ammunition handling to encompass new firing techniques and engagement strategies afforded by the 76mm gun's capabilities. Tank commanders were instructed on the advantages of engaging enemy armor at longer ranges, leveraging the gun's increased penetration and accuracy. This shift in engagement distances reduced the risk of counterfire and improved survivability. Additionally, crews practiced rapid target acquisition and coordinated firing, capitalizing on the Sherman's improved suspension and stabilization systems to maintain accuracy on the move. These refined tactics enhanced the tank's responsiveness and lethality in the dynamic conditions of armored combat. The evolution of armored tactics during this period reflected a broader doctrinal shift toward combined arms and maneuver warfare. Recognizing that tanks alone could not dominate the battlefield, American commanders emphasized coordination among infantry, artillery, engineers, and air support to create synergistic effects. Shermans equipped with the 76mm gun became integral components of these combined arms teams, providing mobile firepower that could be directed flexibly in support of infantry advances or defensive operations. This doctrine emphasized rapid movement, exploitation of terrain, and concentrated firepower to overwhelm enemy positions and disrupt armored counterattacks. Operational experience reinforced the importance of these tactical adaptations. Units employing the upgraded Shermans demonstrated improved battlefield performance when integrating their firepower with supporting arms and maneuver elements. For instance, tank infantry teams coordinated closely to protect Shermans from close-range threats such as anti-tank weapons and infantry ambushes, while artillery and air strikes softened enemy defenses ahead of armored advances. These combined arms tactics mitigated the Sherman's residual vulnerabilities, such as relatively thin armor and limited turret traverse speed, allowing it to operate more confidently and effectively in contested environments. The integration of new ammunition and tactical training also had significant logistical and command implications. Supply chains were adapted to ensure frontline units received adequate stocks of the diverse 76mm ammunition types, balancing the demands of armored engagements with broader operational needs. Command structures emphasized flexibility and initiative among tank commanders, encouraging them to exploit the Sherman's upgraded capabilities through dynamic maneuvering and coordinated attacks. This decentralization of tactical decision-making reflected a maturation of armored doctrine, recognizing that frontline innovation and adaptability were essential in the fluid conditions of late-war combat. Moreover, the continuous feedback loop between frontline experience and ordnance development ensured that ammunition and tactics evolved responsively. Tank crews' reports from the European battlefields informed further refinements in ammunition design, such as improvements in penetration performance or explosive effects. Tactical lessons learned in combat led to adjustments in training curricula and doctrinal guidance, fostering a culture of continuous improvement. This dynamic interplay between technology, tactics, and operational experience exemplified the adaptive nature of American armored warfare during this critical phase of the conflict. The culmination of these efforts was a Sherman tank force that combined enhanced firepower, versatile ammunition, and sophisticated tactical employment to regain parity with, and in some cases surpass, German armored capabilities. The upgraded 76mm gun, supported by improved armor-piercing and high-explosive rounds, allowed Shermans to pose a credible threat to Panther and Tiger tanks, while the evolution of combined arms tactics amplified their effectiveness across diverse combat scenarios. The result was a significant enhancement in the Sherman's battlefield impact, contributing to the sustained momentum of Allied armored operations in the final years of World War II. This phase of development underscored a fundamental principle of military innovation: the effectiveness of a weapon system hinges not merely on its hardware, but on the integration of ammunition, training, and doctrine. The American experience with the Sherman's 76mm upgrade demonstrated how these elements could be harmonized to produce a force multiplier, transforming a previously outmatched tank into a versatile and formidable combatant. The lessons learned from this integration informed post-war armored warfare concepts, emphasizing adaptability, combined arms cooperation, and continuous refinement of tactics and munitions. In essence, the development and deployment of new ammunition types and the evolution of tactical doctrine were indispensable complements to the Sherman's 76mm gun upgrade. Together they maximized the tank's battlefield effectiveness, enabling American armored forces to confront and overcome the challenges posed by superior German armor. This holistic approach to tank warfare, melding technological innovation with tactical ingenuity and operational flexibility, proved decisive in shifting the balance of armored combat during World War II, and laid the groundwork for future developments in armored doctrine and design. The successful development and battlefield integration of the upgraded Sherman tank with its 76mm gun and improved suspension system owed much to the unparalleled industrial capacity of the United States during World War II. American wartime industry mobilized on an unprecedented scale, enabling mass production of these enhanced Sherman variants without compromising delivery schedules or overwhelming logistical networks. This industrial might was a decisive factor in translating the technical improvements conceived by engineers into tangible battlefield advantages, ensuring that frontline armored units were equipped rapidly and in sufficient numbers to influence the course of combat operations. The American approach to tank production emphasized not only technological innovation but also efficiency and standardization. Major manufacturers such as Ford, Chrysler, and other automotive giants adapted their assembly lines to incorporate the new components required for the Sherman's upgrades, including the more powerful 76mm gun, reinforced turrets, and the horizontal volute spring suspension system. These adaptations were executed with remarkable speed and coordination, reflecting the organizational prowess of the American war economy. The ability to integrate complex mechanical enhancements into existing production frameworks without significant delays exemplified the synergy between engineering and industrial management. Ford Motor Company, leveraging its vast experience in mass automotive manufacturing, played a particularly vital role in this process. Its plants retooled to accommodate the EZ8 variant, incorporating assembly techniques that minimize disruption while maximizing output. Chrysler and other manufacturers similarly contributed, each specializing in specific components or variants of the Sherman to optimize production flow. This division of labor and specialization within the American industrial complex ensured that the enhanced Sherman tanks were produced at a scale and pace unmatched by any belligerent nation during the conflict. The coordination between manufacturers was facilitated by the U.S. military's Ordnance Department and associated agencies, which oversaw quality control, standardization of parts, and logistical distribution. This centralized oversight guaranteed that upgraded Shermans met rigorous performance standards and could be maintained effectively in the field. Supply chains were optimized to deliver necessary spare parts, ammunition, and maintenance equipment alongside the tanks themselves, ensuring operational readiness upon deployment. The integration of production, quality assurance, and logistics formed a comprehensive system that sustained the Sherman's frontline presence throughout the war. The scale of Sherman production during this period was staggering. Thousands of upgraded tanks were rolled out within months of the completion of design and testing phases, enabling American armored units to replace losses and expand their operational capabilities simultaneously. This production volume contrasted sharply with the more limited output of German tank manufacturers, who struggled with resource shortages, Allied bombing campaigns, and increasingly complex designs that hindered rapid manufacturing. The American capacity to field large numbers of effective tanks allowed for continuous armored offensives and the maintenance of pressure on German forces across multiple fronts. Rapid deployment of the upgraded Shermans was equally critical to their battlefield impact. Logistical networks ensured that newly produced tanks were transported efficiently from factories to staging areas and then to combat units. Railroads, highways, and ports were utilized to their fullest extent, supported by dedicated military transportation units. Frontline commanders received a steady influx of modernized Shermans, enabling them to plan operations with confidence in their armored strength. This logistical proficiency was emblematic of the broader American war effort, where industrial output and supply chains were as crucial to victory as battlefield tactics. The contrast between American and German armored vehicle production during this period highlighted the strategic advantage conferred by industrial capacity. While German factories labored to produce sophisticated but resource-intensive tanks like the Panther and Tiger, American industry prioritized mass production of reliable, effective vehicles that could be upgraded incrementally. The Sherman's design philosophy, favoring simplicity, ease of manufacture, and adaptability, aligned perfectly with this approach. Consequently, the Allies could sustain armored operations with a consistent stream of capable tanks, offsetting qualitative advantages held by German heavy tanks through quantity and logistical support. This industrial advantage also enabled continuous incremental improvements to the Sherman tank throughout the war. Feedback from combat units was rapidly transmitted to manufacturers and engineers, who implemented refinements in design and production processes. These ongoing enhancements included improvements in armor plating, engine performance, and crew ergonomics, complementing the major upgrades of armament and suspension. The capacity to evolve the Sherman incrementally while maintaining production throughput exemplified the flexibility and resilience of the American wartime production system. Furthermore, the American industrial base's ability to produce large quantities of spare parts, ammunition, and maintenance equipment was essential to sustaining Sherman tank operations in the field. The logistical tail accompanying the Sherman force ensured that battlefield losses could be rapidly repaired or replaced, minimizing downtime and preserving combat effectiveness. This comprehensive support infrastructure was a decisive factor in maintaining armored momentum during sustained campaigns, particularly in the challenging environments of Europe's varied terrain and harsh weather conditions. The collaborative relationship between military planners, engineers, and industrial manufacturers underpinned this success. Military requirements were translated into engineering specifications, which were then integrated into mass production strategies. Feedback loops from frontline units informed ongoing production adjustments, creating a dynamic system responsive to battlefield realities. This coordination ensured that the upgraded Shermans not only met technical standards, but were also delivered in the quantities and timeframes necessary to influence the strategic and tactical situation decisively. In essence, the American wartime industrial complex transformed the Sherman tank upgrade from a technical innovation into a force multiplier on the battlefield. The rapid mass production and efficient deployment of the 76 mm armed EZ-8 variant ensured that American armored units were equipped with a tank capable of challenging German heavy armor effectively. This industrial prowess, combined with engineering ingenuity and tactical adaptation, constituted a critical pillar of Allied armored warfare success. The ability to produce and field upgraded Shermans in large numbers exemplified the integration of technological innovation with logistical and organizational excellence, an integration that proved decisive in the final phases of World War II. German armored forces, confronted with the rising effectiveness of the upgraded Sherman tanks, sought to counter this new threat through a combination of tactical innovation and the deployment of advanced tank variants. German commanders, accustomed to their previous dominance in armored engagements, were forced to grapple with an adversary whose improved firepower and mobility challenged long-standing battlefield assumptions. Yet, despite attempts to adapt, a series of structural limitations within Germany's war economy and logistical framework increasingly constrained their ability to maintain armored superiority, ultimately ceding the advantage to the American forces. In the tactical domain, German units attempted to develop countermeasures that could mitigate the Sherman's newfound lethality. This involved revising engagement strategies to exploit terrain advantages, ambush tactics, and combined arms coordination. German tank crews were trained to prioritize positioning, utilizing hull-down positions, and natural cover to minimize exposure to the Sherman's 76 mm gun. Additionally, German anti-tank units intensified efforts to integrate with armored formations, employing towed and self-propelled anti-tank guns to support tank engagements. These adaptations sought to compensate for the increased firepower of the Shermans by emphasizing defensive tactics and force multiplication at the local level. Moreover, Germany introduced upgraded tank models and variants designed to counter the Sherman's improvements. The Panther tank, already a formidable adversary, saw incremental enhancements in armor and mechanical reliability. The Tiger II, or King Tiger, was deployed in greater numbers, boasting thick armor and an 88 mm KWK-43 gun capable of destroying Shermans at long ranges. Specialized tank destroyers and assault guns, such as the Jagdpanther and Ferdinand, were also fielded to address armored threats more effectively. These vehicles embodied Germany's tactical and technological response to the Sherman upgrade, aiming to restore battlefield dominance through qualitative superiority. Despite these efforts, German armored forces faced critical production and logistical challenges that undermined their operational effectiveness. Allied strategic bombing campaigns targeted key industrial centers, disrupting manufacturing of tanks and components. Resource shortages, particularly in fuel and raw materials, further constrained production capacity and limited training and operational readiness. The complexity and resource intensity of German heavy tank designs slowed production rates, making it difficult to replace losses or field sufficient numbers to overwhelm Allied armored units. These factors collectively eroded the ability of German forces to sustain prolonged armored engagements against the numerically superior and increasingly capable Shermans. Fuel shortages, in particular, had a debilitating effect on German armored mobility and operational tempo. The high fuel consumption of heavy tanks like the Tiger and Panther, combined with Allied interdiction of supply lines, restricted the range and frequency of German armored operations. This limitation curtailed the ability of German forces to execute rapid counterattacks or reposition forces effectively, reducing tactical flexibility. In contrast, the Sherman's relative fuel efficiency and robust supply chains enabled sustained armored offensives and rapid exploitation of breakthroughs, further tipping the scales in favor of the Allies. American engineers continued to refine the Sherman tank throughout this period, implementing incremental improvements that maintained its competitiveness on the battlefield. These enhancements included armor upgrades, mechanical reliability improvements, and refinements to fire control systems. The cumulative effect of these continuous upgrades ensured that the Sherman remained a credible threat to German armor, even as German tanks evolved. This iterative process of improvement contrasted with the more static or resource-limited German development cycle, which struggled to keep pace with Allied innovations and production volumes. The interplay between German countermeasures and American upgrades created a dynamic armored warfare environment characterized by rapid adaptation and escalating technological demands. However, the systemic constraints faced by German forces increasingly limited their ability to respond effectively. The combination of resource scarcity, production bottlenecks, and logistical difficulties meant that German armored units often faced Shermans in unfavorable conditions, lacking sufficient numbers or support. This imbalance contributed to mounting German armored losses and a gradual erosion of their battlefield dominance. Strategically, the Sherman upgrade played a pivotal role in undermining German armored superiority by forcing the enemy into a reactive and defensive posture. As Shermans became more capable of engaging and destroying Panther and Tiger tanks, German commanders were compelled to conserve their armored assets and adopt more cautious operational approaches. This shift diminished the offensive initiative of German armored formations, allowing Allied forces to maintain pressure and dictate the tempo of operations. The psychological impact of facing a more lethal Sherman tank also degraded German crew morale and confidence, further affecting combat effectiveness. The erosion of German armored dominance was not solely a function of technical superiority, but also reflected broader systemic advantages held by the Allies. The American capacity to produce and field large numbers of upgraded Shermans, supported by robust logistics and combined arms doctrine, overwhelmed German forces both quantitatively and qualitatively. The Sherman upgrade thus served as a catalyst that accelerated the decline of German armored power by exacerbating existing vulnerabilities and constraining German options on the battlefield. In sum, while German forces endeavored to counter the upgraded Sherman tank through tactical adjustments and deployment of advanced armored vehicles, their efforts were hampered by production limitations, resource shortages, and fuel constraints. These systemic challenges, compounded by continuous American engineering improvements and effective deployment strategies, ensured that the Sherman's battlefield advantage persisted and grew. The interplay of these factors contributed decisively to the gradual dismantling of German armored supremacy in the latter stages of World War II. Military historians and armored warfare experts have long recognized the 76mm Sherman tank upgrade as a pivotal factor in securing Allied victory during World War II. This enhancement transformed the M for Sherman from a reliable but outgunned workhorse into a more formidable opponent capable of meeting the challenges posed by Germany's advanced Panther and Tiger tanks. The upgrade's significance lies not only in the mechanical improvements themselves, but also in the strategic and tactical advantages it conferred throughout the final phases of the conflict, shaping the course of armored warfare and influencing tank design philosophies for decades to come. Analyses of World War II armored engagements reveal that the 76mm upgrade addressed critical deficiencies in the Sherman's firepower, allowing American tank crews to engage German heavy armor with increased confidence and effectiveness. The introduction of a higher velocity gun, complemented by improved ammunition and suspension systems, enabled Shermans to penetrate enemy armor at combat ranges previously dominated by German tanks. This capability shifted the tactical balance on the battlefield, reducing American tank losses and enhancing offensive and defensive operations. Experts emphasize that this upgrade was instrumental in restoring parity, if not superiority, in armored engagements during the war's decisive campaigns. The Sherman's enhanced role extended beyond mere firepower. Its continued mobility, reliability, and ease of maintenance distinguished it from heavier, more complex German tanks that were prone to mechanical failures and operational constraints. The 76mm upgrade preserved these qualities while augmenting lethality, resulting in a balanced tank design that suited the multifaceted demands of combined arms warfare. Military scholars highlight that this balance was a key contributor to the Sherman's sustained effectiveness, enabling it to perform a variety of roles, from infantry support to tank hunting, with consistent success across diverse theaters of operation. Post-war evaluations also underscore the influence of the Sherman upgrade on subsequent tank development. The experience demonstrated the importance of adaptability and incremental improvement within existing platforms, rather than reliance solely on entirely new designs. The ability to upgrade firepower and mobility while maintaining production efficiency and logistical support became a guiding principle in armored vehicle design. This lesson informed the development of Cold War tanks and continues to resonate in modern armored warfare, where modularity and upgrade potential remain critical considerations. The strategic implications of the Sherman's upgrade are equally noteworthy. By enabling American armored forces to contest German heavy tanks effectively, the 76mm armed Sherman contributed to the broader operational objectives of the Allied campaigns. It facilitated breakthroughs, sustained offensives, and defensive actions that wore down German forces and accelerated the collapse of the Third Reich's armored capabilities. Historians argue that the upgrade's impact extended beyond individual battles, influencing the overall trajectory of the European theater and shaping the post-war balance of power. Recognition of American engineering ingenuity is a recurrent theme in assessments of the Sherman upgrade. The collaboration between military planners, ordnance experts, and industrial manufacturers exemplified the integration of technical expertise with practical wartime needs. The rapid development, testing, and mass production of the upgraded Sherman reflected a capacity for innovation and adaptation that was crucial in addressing the evolving challenges of armored warfare. This accomplishment is often cited as a testament to the resilience and resourcefulness of the American war effort. The psychological dimension of the upgrade's impact also merits attention. The knowledge that Shermans could now effectively counter German heavy tanks boosted the morale of American tank crews and commanders. This confidence translated into more aggressive tactics, greater willingness to engage enemy armor, and improved combat performance. Conversely, German tank crews faced the demoralizing reality of a more capable adversary, undermining their psychological advantage and contributing to operational hesitancy. The interplay of technological and psychological factors thus shaped the dynamics of armored combat. Lessons learned from the Sherman upgrade continue to inform military education and doctrine. The case study illustrates the necessity of aligning technological innovation with tactical adaptation and industrial capacity. It demonstrates how continuous feedback from the battlefield can drive effective improvements, and how balanced design considerations can yield versatile and resilient combat vehicles. These insights have influenced not only tank design, but also broader approaches to military modernization and force development. In conclusion, the 76mm Sherman tank upgrade stands as a defining example of how targeted technological enhancements, combined with tactical evolution and industrial mobilization, can decisively alter the course of warfare. Its role in securing Allied victory underscores the importance of adaptability, innovation, and integrated planning in military success. The legacy of this upgrade endures in the principles it established, shaping the future of armored warfare and exemplifying the enduring impact of American engineering during World War II. American engineers' timely and innovative modifications transformed the Sherman tank from a dependable but outmatched vehicle into a formidable opponent that reshaped armored warfare during World War II. This upgrade was not merely a technical enhancement, it was a strategic pivot that altered the balance of power on the battlefield, enabling the Allies to meet and overcome the formidable German armored threat. The story of the Sherman's transformation stands as a testament to the ingenuity, industrial capacity, and tactical adaptability that defined the American war effort. Initially conceived as a reliable and easily produced medium tank, the Sherman faced significant challenges when confronted with the superior armor and firepower of German Panther and Tiger tanks. The original 75mm gun, while adequate against earlier threats, could not consistently penetrate the thick frontal armor of these adversaries. Recognizing this vulnerability, American engineers embarked on a focused mission to enhance the Sherman's lethality without sacrificing its hallmark mobility and mechanical reliability. The result was the integration of the high-velocity 76mm gun, an upgrade that significantly improved the tank's ability to engage and defeat heavy German armor. Complementing the firepower enhancement were critical mechanical improvements, including the adoption of the horizontal volute spring suspension system, which provided the Sherman with improved stability, cross-country mobility, and crew comfort. This combination of increased firepower and superior mobility elevated the Sherman's battlefield effectiveness, allowing it to operate more aggressively and with greater precision. The M4A3E8 EZ8 variant emerged as the embodiment of these improvements, representing a new standard for American armored vehicles. The impact of the Sherman upgrade extended beyond its mechanical features. It necessitated a fundamental evolution in tactical doctrine, emphasizing combined arms operations, integrated fire support, and maneuver warfare. Tank crews were trained to exploit the Sherman's enhanced capabilities, coordinating closely with infantry, artillery, and air units to maximize battlefield impact. This doctrinal adaptation ensured that technological improvements translated into tangible operational advantages, reinforcing the Sherman's role as a versatile and effective combat platform. American wartime industrial capacity played a vital role in the upgrade's success, enabling rapid mass production and deployment of the improved Sherman variants. Manufacturers such as Ford and Chrysler adapted their production lines to incorporate new components without interrupting output, ensuring that frontline units received a steady supply of upgraded tanks. This industrial efficiency contrasted sharply with German production limitations, where resource shortages and complex designs constrained the deployment of advanced armored vehicles. The scale and speed of American production provided a decisive quantitative advantage. German armored forces struggled to counter the upgraded Sherman effectively. While they deployed improved tank models and refined tactics, systemic challenges including fuel shortages, production bottlenecks, and logistical difficulties hampered their efforts. The cumulative effect of continuous American engineering refinements and tactical innovations ensured that the Sherman maintained a battlefield edge, contributing significantly to the gradual erosion of German armored superiority. The psychological impact on German crews, faced with a more lethal and mobile adversary, further influenced the dynamics of armored engagements. Post-war assessments affirm the Sherman upgrade's vital contribution to Allied victory and its lasting influence on armored warfare. The upgrade demonstrated the strategic value of adaptability, showing how incremental improvements to existing platforms could yield substantial battlefield benefits. This approach informed subsequent tank development philosophies, emphasizing modularity, upgrade potential, and the integration of technological advancements with tactical doctrine. Ultimately, the Sherman tank's surprising upgrade stands as a monument to American engineering resilience and innovation. It transformed a workhorse vehicle into a symbol of armored effectiveness, shifting the dynamics of World War II's armored battles decisively in favor of the Allies. The legacy of this upgrade endures, illustrating enduring principles of military success, the fusion of technological advancement, tactical evolution, and industrial capability. The Sherman's transformation remains a powerful example of how timely innovation can redefine the course of warfare and secure victory against formidable odds.